So this is video number 5 of the series of the ZiptieAI video series. So up till now, in the previous 2 videos, I talked about Epic 1, building an FPV drone. Epic 2 is building and flying the Pixhawk drone. This video is about Epic 3, adding AI to the Pixhawk drone. So if we go back to the Pixhawk drone, see if I can get a picture here somewhere. So this is my first flight test, indoor flight test of the Pixhawk drone. I took the legs off so that I could strap it down to the table. But in the Epic 3, what I did was I added a camera, Jetson Nano, and a Jetson Nano battery so that I could fly this copter on a mission, and if the copter recognized a person in front of the copter, then the copter wouldn't recognize it. The Jetson Nano would recognize it. And if the Jetson Nano recognized a person, then it would command the Pixhawk to land the computer. So basically you have what some people would call intelligent. You have AI controlling your copter so that your copter could react to the environment. It may not seem like a very big deal, but you have to get all these connections set up. You have to write a small Python program, and then you have to figure out how you're going to test this. So if you get the basic small program working, that's a big deal, because then you can move on fairly quicker to more complex kind of programs, AI programs. There is one thing about this program. This AI program here just makes the copter land. And the reason I did that is in this Epic, adding AI, there's one problem here. The problem is if you've got an artificial intelligence program on that Jetson Nano, and you want to do something fancy, like you want to tell the copter to do something unusual, how are you going to test it? So, if you have to test the program, and a program is made to run only when you're actually flying a mission. That's a problem. We get into the solution to that problem is in the next Epic, Epic 4, where there's a way to test this. You test it not actually flying a mission, but flying a virtual mission. But setting up that is a bit of, difficult. So in this Epic, the goal here is to, let me get on the page. This Epic with AI using a Jetson Nano. Okay, sorry, I was on the wrong page. So the objective here is just to get the basics working first, and just making it land. That's an AI program that is pretty much safe without testing using simulation. So let's see here. So in this Epic, the first thing you're going to do, you got basically three things you have to do here. You have to configure the object recognition on the Jetson Nano, and that can be a bit complicated. And then you have to do the kitchen build and test, and then the field test. So configuring the object recognition, there's a document, here's on Gdrive, And I call this document Dusty 10 Lines of Code. And this because I took basically a NVIDIA demo and by an NVIDIA employee called Dusty, very intelligent person, who wrote this 10 lines of code to get an AI program running on the Jetson Nano. And so this kind of shows what I did. I followed his example, and this is where on my setup at the very end, this is a screenshot from my computer where I was running a video of a person, and I pointed my camera at the computer screen, and it recognized the person. So I had my object detection working. So that's documented in that Word file. So you get the object recognition running. Then after that, you want to do a kitchen build and test. And this is where things get a little bit complicated. So there's several things that I had to do. I had to install something called Flatpak, because what I'm doing here is I'm running QGC, a Q ground control on the Nano, and you're having to wire up some things, and then you're doing the kitchen test. There's actually quite complicated. It's kind of hard to explain. But let's look at the kitchen test document. See if we got any good screenshots here. So here is where I'm doing the kitchen test. There were some complications with getting. One thing that you have to do here is you have to find a way to get this object recognition starting up on the Nano automatically all by itself, and there were some complications with that. So the goal here was I go out to the field and I fly the copter, and all I have to do is power up the Nano, power up the Pixhawk, and I don't have to bring my computer with me, and everything boots up on the Nano as required, so that everything runs and that the copter flies and it recognizes you. There's quite a few complications I ran into with that. Did find a solution, but for this video, it's not something you probably want to talk about. But here's a video. Here's a screenshot showing my test setup, how I did this. So I had the Pixhawk 6C running here, and so here's the Jetson Nano with the camera, and here's the Pixhawk. Over here is the Jetson Nano. The screen is the screen for the Jetson Nano, and it's running Q ground control, and it's running the Pi script. It's actually going to recognize the person recognize the person. And then over here is a Windows machine that has you see this telemetry radio right here. It's connected to a telemetry radio on the Pixhawk. So this is running Q ground control. So the reason I'm running Q ground control here is I want to monitor what the flight mode is of this Jetson Nano. The idea is You you have the Jetson Nano in a certain flight mode, like stabilize. And then I put this camera in front of a picture of a person or in front of me, and the Jetson Nano is going to run AI on that. It's going to recognize a person, and then it's going to change. It's going to command the Pixhawk to change the flight mode. And then I'm going to see that over here on my Windows 11 computer. And that did work. So here's a little bit more of a close-up with my messy wiring and all that stuff. So, and here's commands being sent. There's me, and here is showing a person was recognized. This NVIDIA object recognition really works well. So, and then you see here on the Windows computer the land mode. In the end, it worked because I'm in the land mode. So that was the kitchen test. Okay, the kitchen test. And then after that, we have the field test. So this is where I ran into a problem. Had some bad weather here, and I've been busy doing these, getting the wiki in good shape, and then doing these videos, which I've never done before, and which you can tell by this is not really my thing, doing videos. But I took this thing out to fly. It wasn't reacting. So I take it back to my test setup here at home, and everything was working fine. But I only tested it one evening. And so I might have to take my Windows 11 computer out to the field and then use the telemetry to connect to Pixhawk and see what's going on, what the problem is. I don't think it's a big problem. It's probably some small problem. But it wasn't reacting, the flight mode. So, but I did get it to work. I did get this to work previously when here, let me show you on a blog. When I didn't do a mission, all I did was manually fly it. Here's the flight test outdoors. Now, what happened here is the copter was just sitting in the air. I manually flew it and put it into hold mode, so it's flying in the air. I'm actually behind the copter while I'm doing this, and the copter's just sitting there in the air flying itself. I'm walking around to get myself in front of the camera to see if the copter is going to react. So I don't do anything at this point. So you see, what happened there was, this camera's pretty good. As soon as I got within the field of the camera, the J Nano recognized that there's a person in front of the copter. And then it set the command to the copter to land. So the object recognition is working, but when I tested for the mission, something was not right. So I still have to go back and figure that out. I'm not sure what the problem is. And I had some bad weather, like I said, and I was doing some other stuff. So this was a really big deal for me. I've been working on copters for 6 months. I got distracted by some project I was doing for some other person. But this was really my goal, to get an intelligent copter flying in the air. Now, you look at this example and you think, oh, that's kind of a simple example. And you're right about that. But there's a lot of complicated getting things set up. Like making sure the battery is going to power the Nano, getting the connection from the Nano to the Pixhawk, getting the Python required PyMav link all set up. It was really kind of a really complicated thing when you do it the first time. And there was nothing like what I just showed you. There was nobody who put a video together in the documents that showed you basically what you need to do. So that was really a big deal for me. And so that's the end of this video.